we'll be solving one question that is of increasing triplet sequence subsequences. So what it says is like we will be given an array nums, okay, and we have to return true if there exists a triple of indices, that is I, j, k, such that I is less than j and j is less than k, and with the array elements at I, j, and k in this particular order. And if no such indices exist, return false. Okay, we can take an example of 1, 2, 3, 4, 5. Okay, if I write over here 1, 2, 3, 4, and 5. Okay, and here we can find out a subsequence which is in the required order. Okay, as you can see, 1, 2, 3 itself uh, is in the required order. Like if we take I over here, j over here, and k over here, then what we will get is the subsequence with I less than j and j less than k, and with this array elements as following this rule. Okay, first and foremost approach that I thought of was like to go with the three-pointer approach. Now what it says that is, let's take the example of the second, a little bit comprehensive example is here. So let's just take example of this. Okay, so we have this array of 6 elements, and my first approach was to use three pointers. Okay, these three pointers will be letter B, I, J, and K. Okay, firstly I will fix the K at the end of array. Okay, then I will find proper I and J elements according to the specified rule, specified condition which is given. So what I will be doing that for every k, for every k I will be having a j, fixing a j, then traversing I from 0 to j minus 1, and seeing if there exists any subsequence which is following the proper order, and at the end I will be doing j minus minus. So I will be repeating this loop, and as you can see, O of n over here and O of n over here, so it will be taking O of n cube. Okay, so it will be taking O of n cube, and it was working very fine for all the test cases, but one of the test cases here like this came up, and yeah, mera code fat gaya. Okay, so then I have to think of some approach which can be which can solve this problem within required complexity, time complexity. So what I can think of is a greedy approach. We can use it for the same. So what the greedy approach, what it says is, like you have one first number, okay, and you have you just declare it with the maximum value, and we are also going to have a second number, and what we are going to do is we are going to declare it with the maximum value, and then what we will be doing is, so what's my scenario is like, I will have what the algo says is, so whenever element, the first will be find out. Okay, if it is less than the algo will be, if an element, for example e, traversing to the a array, this is a for each loop. Okay, so whenever, okay, I will write straight away the code. Int e traversing to, so this is a e variable which will be traversing to the array, and if we find e less than or equal to the first number. Okay, then what I will do is I will just update first number with the e. Okay, else if e is less than equal to second number, then I will just update second number with the e. Okay, elsewise when this first and second number are both are less than the e element, so that will be the case. That will be a particular case when this condition will be satisfied. That is, nums will be less than the first number will be at I, second number will be at j, because we are storing that in a increasing subsequences. So here we will be returning true. Why? Because we are able to find a number e which is greater than both second number as well as the first number. Otherwise, we will be continuing the loop. And if it comes to the loop, comes out of the loop without returning true, then there does not exist any subsequence which can support this condition. Okay, so how it happened in reality is, let's see. So I'm naming the first number by f. Okay, second number by s. Let's see. So as a first element will be 2 first, because it will be less than the maximum value, that is infinity. So let's 2 will be okay. Now e, as now e will be 1. So let me use a debugger, or no, I can simply show you from here also. Okay, so 2 is considered to be a first number now. Okay, then we just move to 1 and we see whether that 1 is less than the first number. Yes, so first number will become 1. Okay, now just again we traverse and we come at 5, as 5 is not less than or equal to the first sum, so we move here. As it is less than the second number, that is infinity so far, so we'll just name it as s. Okay, then we go at 0 and we found that our first condition is turning to be true, so we just move it f. Then again s will be coming, and then we will be finding a sixth element which will not be satisfying both of the conditions. Like it will be it will not be less than first num, or not it will be less than the second num. Okay, once we find this, so this pair is forming the condition subsequence which is satisfying this condition. Okay, here we can take an example, one more example. I think it will be fine. So this way we can do this in O of n, time complexity, and as the space complexity is O of 1. So if I try to run this code, I got accepted and submitted and we got accepted. That's it.
तो अच्छा, एक चीज़ रह गई थी कि जो हमने फर्स्ट अप्रोच डिस्कस की थी ओ एफ एन क्यूब वाली 3 पॉइंटर्स वाली, तो उसमें के फिक्स कर रहे थे लास्ट पे, ठीक है। फिर जो जे है ना वो k-1 पे फिक्स करना है और आई को रन करना है 0 से j तक। ओके, फिर जे को डिक्रीमेंट करते जाना है जब तक आई इज़ लेस देन जे। टाइम लिमिट एक्सीडेड आएगा उसमें। सो ये थोड़ा इंट्यूटिव नहीं है ये वाली अप्रोच, but once you have come across this, you will be able to solve the similar questions like longest increasing subsequence and all that is there na. Okay, so I hope that you have gained something from this. ठीक है, लास्ट टाइम एक जोक सुनते जाओ यार। ठीक है, तो क्या होता है कि पति के बाल झड़ रहे होते हैं बहुत स्पीड से, तो पत्नी एक दिन बोलते हैं कि अगर ऐसी स्पीड से तुम्हारे बाल झड़ते गए ना तो मैं तो तुझे तलाक दे दूँगी। पति बोलता थत तेरी भी, मैं ऐसे ही इनको बचाने की कोशिश कर रहा हूँ। ओके गाइस, मिलते हैं फिर एक नेक्स्ट क्वेश्चन के साथ।